Today we're introducing ConformAR. Education is seeing increasing and accelerating use of online video conferencing tools to replace conventional teaching environments. These tools are sufficient to recreate parts of the classroom experience, but are also underdeveloped in face of increasing use of touch, video, and interactive computing amongst learners. Some disciplines like computer science transfer well to digital interfaces and video, but others like mathematics still rely heavily on handwriting and physical media. Also, a webcam's narrow field of view requires educators to frequently erase what they write, which can induce unwanted cognitive load.
We may be able to remedy this with augmentations to the video teaching environment. We know that young students benefit from gesture and touch-like math interactions, and that augmented reality can support math learning. Hand gesture may also have a role in how learners determine significance.
So, we set out to create ConformAR, a webcam-based AR-capable tool for completing math exercises using simple gestures. To our knowledge, ConformAR is the first combination of 2D video-based gestures and AR to control math objects. ConformAR enables students and educators in teaching environments where materials are pre-planned to practice and solve problems without requiring physical media or handwriting. We explore a simple gesture design by example through the first steps of deriving the quadratic formula. Our selection of gestures builds upon the observation that users reliably agree on gestures that resemble direct physical manipulations. So, we implement gestures where only a single cursor or finger is needed at a time, and interactions resemble physical manipulations and handwriting analogies. ConformAR also includes a text input for special math operations, as well as a persistently visible history of solution steps to reduce cognitive load. Users toggle a gesture mode by pressing and holding a key. In this mode, cursor and finger movements are tracked. Hand tracking interactions with ConformAR replace cursor interactions when using video. ConformAR detects initial and final gesture locations to modify math symbols, and a red pop-out effect draws attention to cursor or finger locations. All of this is implemented using HandTrack.js and D3.js and runs in a browser. We also co-developed a cursor-based graphical user interface to compare AR interactions to GUI interactions.
We piloted ConformAR through a short questionnaire done by post-secondary educators involved with teaching technologies. Respondents were asked Likert-scale and open-ended questions compare AR and GUI interactions in the context of math-related classroom. We also asked respondents to comment on the limitation of ConformAR and other teaching tools, as well as the future of math education. All respondents noted a movement away from traditional teaching tools. Respondents also strongly agree that interactive tool has a place in math-related classroom, but they seem divided on how common AR would be and also divided on whether notes homework should be typed and handwritten. Respondents also expressed a slightly preference for AR interactions over GUI interactions in ConformAR.
However, our sample is too small to really make conclusive results. Further evaluation should be done to account for other stakeholders, like students. Usability and accessibility were not formally evaluated, but we think they should be, as ConformAR could be targeted to serve specific accessibility needs. Looking onward, extensions of ConformAR to head-mounted see-through displays, in combination with sophisticated portable hand tracking tools, would be inspiring continuations of this work.